proposed approach, evaluation, and conclusion. So the next step is about introduction. Introduction is nothing but like the objective is to improve the sentiment classification accuracy and efficiency in an information retrieval system using SVM and future engineering. So talking about sentiment analysis, the sentiment analysis is a crucial tool for understanding the emotion and opinion expressed in a text data. So in this project, we focus on how sentiment analysis can be improved using machine learning techniques, especially SVM combined with text summarization. So the pre-processing overview, the next step about the first phase of pre-processing, that pre-processing the text data is includes the tokenization of the text, removing stop words, eliminating the character punctuation and stop words, applying the stemming or limitation for the word of normalization. So the technique used for pre-processing is tokenization, stop word removal, limitation, normalization. So tokenization is about splitting the text into word or phrases. Stop word removal is nothing like it will eliminate the word that don't contribute to meaning. Like example, and the about the limitation, convert a word to their base form. The, the word will convert to the base form. Example, running to run. The ing will be removed. Normalization is about ensuring the uniformity across the text for better analysis. So the next step of text summarization is applied to reduce the complexity of input data. To the reduce the complexity of input. There are two main techniques are used in text summarization, which is extractive summarization, where the key sentence are selected. Where in extractive summarization, the key sentence have been selected. So about the abstractive summarization, where the new sentence are generated. So talking about the extractive and abstractive summarization, both has advantage and disadvantage. So extractive summarization focus on only the advantages focus on only key phrases, but the disadvantage is it may miss the context. So the abstractive summarization is used to generate a new content and capture the deep meaning. So the disadvantage is the more complexity requires to NLP techniques. So going to the future engineering is the next step. Once the text summarization once the text is summarized, the future engineering begins. This involves extracting meaningful features such as sentiment-related words, syntactic structure, and conceptual signals. Techniques like bag of words and TF-IDF helps to quantify the importance of the word in the sentiment classifications. So not only the bag of words and TF-IDF, there is a sentiment lexicons and word embedding with the future engineering. So talking about the bag of words with TF-IDF, the term frequency is measured to, like term frequency is reference to a key part of a feature engineering. How often a word appears in a document. The term frequency is talk about how often the word is occurs in a document. So while talking about inverse document frequency, which is IDF, evaluates how rare a word can be across in all documentation. So combining these are the formulas of TF and IDF. Combining these both, uh, we can get a better accuracy. Like combining these gives us a score that highlights the importance of words helping to improve our accuracy of sentiment classification. So, talking about sentiment lexicons and word embedding, sentiment lexicons is used for com- compare a word to predefined predefined sentiment dictionary. So where the polarity extracted from positive or negative of sentiment have been bearing efforts. Like it's capture the deeper meaning. We also use sentiment lexicons and word embedding. Lexicons helps us match words and predefine sentiment scopes, while word embedding allows to understand the sentiment relations between words. This enables us to consider not only individual words but also their context in the sentence. Ah, about support vector machine. The next, we use support vector machine to perform the sentiment classification. SVM is a powerful binary classifier that finds optimal decision boundary, which is in positive or negative in sentiment classes. By training the SVM in our future vectors, we can effectively categorize a new text on documentation. So, like we can categorize with the positive and negative by using this SVM. So, about the post processing and evaluation, after classification, we enter to the post processing. Um, where we evaluate the model's performs using the metrics like precision, recall, F1 score. These are the metrics as give us understanding of the model success is in identifying the current sentiment in the given data set. This will help us to find the accuracy level where we get correct data of this. Talking about this, the accuracy of we get about in this project, the 72% of sentiment analysis classification. So, so the proposal approach will be like ROC curves analysis. So ROC curve analysis is about plots the true positive rate and false positive rate, especially like one negative to positive. So AUC is about area under the curve, measures the model ability to differentiate between sentiment categories. The higher AUC is a better performance, visualizing how the SVM model distinguishes between positive and negative and neutral set. So also I talk about only positive negative, and there also the state like it will be in between. So in between we can take as a neutral sentiment. So the proposed approach will like data collecting, pre-processing, summarization, and feature engineering and SVM classification. So the evaluation result, our result showed the SVM based model achieved accuracy of 72, classifying the sentiment categories. So about this, the conclusion of the approach is conclusion of this approach is in conclusion, the project demonstrates that by integrating text summarization, future engineering, and machine learning techniques like SVM, we can improve the accuracy of a sentiment analysis in information retrieval system. So future work could be involved in optimizing the SVM models further on exploring ensemble learning techniques to boost our performance. Mm. So the future work will be improve the model accuracy by optimizing the future works of extracting tuning SVM parameters like hyperparametric tuning and exploring the ensemble techniques.